Here we're going to be solving radical equations, equations involving square roots. And let's start with a real simple example. The square root of x equals 10. We want to get just x itself. How can we go from the square root of x to x? Well, we can undo square roots with squaring. But are we allowed to do that? Can we square both sides of an equation? Well, yes, but there's two things to watch out for. Two warnings that go along with squaring both sides. First of all, you can square both sides altogether. The entire left side squared equals the entire right side squared, but you can't just go through and square individual pieces. So for example, in the equation 10 equals 3 plus 7. I'm not allowed to go through and square the 3 and the 7 individually. It's not true that 10 squared equals 3 squared plus 7 squared. You can see that the numbers don't match up. But you can say, okay, take the 3 plus 7 and square the whole thing. Then 10 squared would be equal to the sum of 3 plus 7, and then that whole thing squared. And remember what happens when you take a binomial, something plus something or something minus something, and you square the whole thing. You get the first term squared plus or minus 2 times the first thing times the second thing, plus the second thing squared. So for example, if I took the square root of x minus 3 and I squared that whole thing, I would get the first thing squared, square root of x squared, which would just be x, minus 2 times the first thing times the second thing, so 2 times the square root of x times 3, which would be 6 times the square root of x, plus the second thing squared, 3 squared would be 9. And notice that does still involve a square root of x. The other thing to watch out for, the other but involved in, yeah, you can square both sides, but if you do that, you have to be a little suspicious of the solutions you end up with because they might not work in the original equation. Here's an example of that. Suppose our original equation was the square root of x equals negative 10. We square both sides. The square root of x squared would just be x. Negative 10 squared would be 100. But does that work? If we go back to this equation and plug 100 in for x, is the square root of 100 equal to negative 10? No, because when we just say the square root of 100, we mean the principal or positive square root, not the one that's negative. What happened here is that we had two sides of an equation that were not equal because one of them was positive and one of them was negative, but then when we squared both sides, they became equal, where they didn't used to be. A positive squared is positive, a negative squared is positive. They ended up equal, but they weren't equal originally. So in this example, 100 is what we call an extraneous solution to this equation. It doesn't really work in this equation. So here's our strategy, our procedure for solving equations involving square roots. Step 1, isolate the radical. That is, get the radical part, the part that's the square root of something, by itself on one side of the equal sign. Then square both sides. And remember, if there's more than one term, you have to square the whole thing. You can't just go through and square individual terms. Then solve for x. And finally, any solutions you get, check them in the original equation. They might or might not work. If they don't work, discard them. Okay, let's try some examples. The square root of x plus 4 equals 3. First thing we need to do is isolate the radical, the radical already is by itself on one side of this equation. So that's taken care of. Now square both sides. The square root of x plus 4 squared equals 3 squared. And squaring over here just undoes the square root. The square root of something squared is just the something. So that's x plus 4 equals, and then 3 squared gives us 9. Now to finish solving, we just have to subtract 4 from both sides, and we get x equals 5. But we got to check that. If we go back to the equation and put 5 in for x, is the square root of 5 plus 4 equal to 3? Well, 5 plus 4 is 9, and the square root of 9 is equal to 3, so that checks out. 5 is the solution to this equation. Let's try this one. X equals the square root of 41 minus 5x plus 7. Notice the plus 7 is not under the radical sign, but the 41 minus 5x is. So first thing we want to do is isolate the radical. Get it so that the radical expression has one side of the equation all to itself. That means we want to get rid of the plus 7, and we can do that by subtracting 7 on both sides. Then x minus 7 equals the square root of 41 minus 5x. Now we can square both sides to undo the square root. X minus 7 squared, and notice it's the whole thing squared, equals the square root of 41 minus 5x squared. Okay, what's the result of all that squaring? Well, if you take x minus 7 and square that, remember what happens. You get the first thing squared minus 2 times the first thing times the second thing plus the second thing squared. So x squared minus 14x plus 49 equals, and then over here, squaring just undoes the square root, 41 minus 5x. Okay, now we have what looks like a quadratic equation. Let's see if we can get everything on one side equal to 0 on the other side, and then we might be able to solve by factoring. Okay, so get rid of the 41 minus 5x, add plus 5x, and subtract 41, and we get x squared minus 9x plus 8 equals 0. Think we can factor that? If we can't, there's always the quadratic formula, but I think we can factor this. Can you see what the two factors are? X minus 1 times x minus 8. Because if you multiply that out, it's x squared minus 8x minus 1x plus 8. Now set each factor equal to 0. X minus 1 equals 0, or x minus 8 equals 0. So x equals 1, or x equals 8. Are we all finished? No, we are not. There's still something we have to do. We have to be suspicious of these, and we have to check them in the original equation. First, let's check what happens when x is 1. Is 1 equal to the square root of 41 minus 5 times 1 plus 7? Well, let's see. 5 times 1 would be 5. 41 minus 5 would be 36. The square root of 36 would be 6. And 6 plus 7 would be 13. Is 1 equal to 13? I think not. So, that didn't work. 1 is actually not a solution. It's extraneous. Okay, what about the other? What about x equals 8? Let's check that. What happens if we go back here and put 8 in for x? Is 8 equal to the square root of 41 minus 5 times 8 plus 7? Well, let's see. 5 times 8 would be 40. 41 minus 40 would be 1. The square root of 1 would be 1. And then 1 plus 7, is that equal to 8? Sure. 8 is equal to 8. The equation does check out. So that is a solution. So the one solution to this equation, the one thing that you can put in for x and have the equation be true, is 8. By the way, we got these two possible solutions, one of them worked and one of them didn't. It's possible for both of them to work. It's possible for neither of them to work. So I could come up with examples for any of those. I just think it's most fun when one works and one doesn't. And now for a more advanced example, and what makes this more advanced is that there's more than one radical here. That means when we try to isolate the radical, we can't really isolate them both at the same time. They both can't have a side of the equation all to themselves, because then where would the 6 go? But we can at least isolate one of them. So I chose to leave the square root of x minus 2 where it is, but subtract the square root of x on both sides. Now when I square both sides, square root of x minus 12 squared equals 6 minus the square root of x squared. What happens when I multiply those out? On the left, squaring undoes the square root, and I have x minus 12. On the right, when I multiply this out, I get the first thing squared minus 2 times the first thing times the second thing plus the second thing squared. So 36 minus 2 times 6 times root x plus root x squared would just be x. What can we do to clean this up? Well, we can subtract x on both sides. That'd be nice. And we could subtract 36 on both sides. Then we have a negative 48 equals negative 12 times the square root of x. And why don't we go ahead and divide both sides by negative 12? Then we get negative 48 divided by negative 12 is positive 4 equals the square root of x. Now we can square both sides again, and we get that x is 16. So right now that's only a possible solution. We have to check and see if it works. If we put in 16 for x, we're looking at the square root of 16 plus the square root of 16 minus 12 equals 6. I put a question mark here because we're checking whether it really does equal 6 or not. Is the equation true? Well, let's see. 16 minus 12 under this radical sign would be a 4. And then the square root of 16 here is 4. The square root of 4 here is 2. And 4 plus 2 is equal to 6. That checks out. So 16 is the solution to this equation. Okay, so that was solving radical equations. I'm going to end this video here. And then in the next video, we'll talk about solving absolute value equations. See you then.